Good afternoon, everyone. I'm going to present a parasitic relationship between two shield volcanoes, which are associated with the Mare Tranquillitatis region, presented as a background image. So Mare Tranquillitatis is located on the eastern near side of the moon, and it is very unique region compared to all other basins because it doesn't show a U shape, like its impact originated, and it should be a ball shape or U shape, but it does contain a larger shield volcano, which is Scottish shield, nearly 400-kilometer diameter shield. And on top of that, at the Mare highland boundary of Mare Tranquillitatis, there is another shield which is nearly 70-kilometer diameter shield. So both of these shields are nearly located and associated with the Mare Tranquillitatis and shows nearly 1.5 kilometer elevation compared to the surrounding region. So to understand the composition, we used Chandrayaan-1 moon mineralogic mapper datasets, LRO diviner datasets, and to understand topography, morphology, and tectonics, we used NAC, LULA, and BAC datasets, and to understand presence of pyroclastic deposit, we used mini-RF datasets. This is integrated band depth parameter false color composite image of the Gardner shield, and we found the color variations, and based on those variations, we delineated volcanic units of this region, which are 16 in number. So out of 16, 15 are effusive flow unit, and the central S11 unit shows explosive unit, and there is a huge lava channel coming out from the southern region of the shield, which is nearly 5-kilometer thick, and it is cutting down the surrounding hill and flowing up to the Mare Tranquillitatis floor at the northernmost part up to tens of kilometers. This is a CF map. So CF value for the Gardner shield is varying from 8.3 to 8.5, which is indicating a mafic material within the area, mostly high calcium pyroxene bearing material, and at fewer places olivine bearing material. Diviner H parameter map shows moderate value for the H parameter, which indicates a thinner regolith layer on the shield. So these are the spectra collected from each of those volcanic units from the fresh crater, which are nearly 1 kilometer diameter, and we calculated band depth parameter like band area, band ratio, and band depth from all of the spectra, and plotted those values against the laboratory measurement from the Cloutis et al., Gaffey et al., and Klima et al. And the result shows the presence of high calcium pyroxene bearing material and a fair amount of olivine bearing material for all the effusive unit, and for the explosive central unit, it shows mostly pyroxene bearing glassy material. So this is the central pyroclastic bearing unit S11, and we created a NAC 3D image which shows a prominent subsidence as well as very darker material with the NAC data, which is located at the central part of the caldera of shield, which is S10 is the caldera, S11 is the pyroclastic deposit. So H parameter value shows a moderate range, right, like 0.06 to 0.8. S11 unit shows higher CF map, higher glass band depth parameter, and lower rock abundances, and higher CPR value, which indicates a darker, smoother, and finer material for this region. These are the glassy spectra, and all the parameters we compared with the mafic glass mixture of laboratory experiments from Horgan et al., which also suggest a presence of high calcium pyroxene bearing glassy material for this region. So Kochi shield shows a relatively longer flowed and voluminous unit like T21, T18 within the Mare Tranquillitatis region, and we compared these all spectra with the Gardner shield analysis, which are completely overlapping on each other, and it suggests a relationship with a compositional relationship between two shields. This is a morphological map. The map shows most of the morphology which should be which can be expected at a volcano. So it contains a caldera, central subsidence, parasitic cone lineaments, and major faults. And there is a I should point here. So there is a major fault within this area, and this is a central fault. So for origin of the S1 lava channel, we expect it should be from this secondary displacement from this fault, rather than having any association with the central part of the region. And all these are effusive flow units showing a smoother topography within the region. And these are the scarp boundaries. All over the area shows all the normal faults, which shows extensional retime within the region. This is a S11 pyroclastic deposit, and with the wake data, we can see it's a darker than the surrounding material. This is a normal fault. Here is a major subsidence like graben, and the secondary displacement of the major fault and possible origin for the S1 unit. And this is a partially developed caldera ring structure for the shield. Okay. For the Cauchy shield, all the morphological and topographical studies are still in progress, but these are the initial results, which shows caldera summit within the region. Based on, both the shield shows all kind of domes, faults, and lineaments, and major topographic relevance, which indicates a possible parasitic relationship for this region. Thank you.
Other questions?
Being from Brown University, this might be a naive question, but what exactly do you mean by a parasitic relationship?
So I'm interpreting it as a common source for the lava eruption for both of the shield. The reservoir, the Cauchy shield is around 400 kilometers, so it should have a main reservoir, and there should be another magmatic chamber below the Gardner shield, and both are composed from the same region. Thanks.
Time for one more?
Yeah, Chuck Wood looked at the Gardner Mega Shield as part of the Lamont Gardner Megadome alignment.
Yeah.
You looked at some of the other features that are part of that alignment to see if they might in some way correlate with what you're seeing on the Gardner Megadome. So something like, the Janssen volcanic complex.
Like what kind of feature? I'm not getting.
So you're looking at a possible relationship here between these two volcanic features, but there are other volcanic features in the area that have been hypothesized to perhaps be related. Have you taken a look at any of those other features?
Like volcanic features, you are saying?
The other volcanic features in the Janssen Gardner Megadome Alliance alignment.
Oh yeah. I know you are talking about the eastern correlation. I read that paper. No, I never looked on that part of this region, but this Cauchy shield was part of my PhD work, and then I just analyzed with my postdoc position the Gardner crater, and I found a really good correlation, because it's hard to delineate the eruptions for this both region. The lava is just merging. Still, we found it, and then I thought to give it a try to just see the correlation based on the composition. It shows the correlation. But yeah, I will look at the eastern part. But the other thing, those parts shows a positive gravity anomalies, and that's why they correlated it. But the one Lamont region is subsided. It's not a shield. So these are the shield, and it's a positive topography. Like Lamont is a subsidence feature, and there are many possibilities for why it is showing positive gravity anomaly. But these are topographic highs, so I think it makes more sense to just compare the topographic highs compared to the topographic lows, because these are the shield and it is not the shield. The Lamont Mascon is a subsidence feature. It's not a shield. It's a negative relief feature.
It'd be interesting to see if perhaps they do.
A compositional
have a
relationship?
composition
Yeah, I'll
that
look
share
at it for
these
sure.
slopes.
Yeah, I'll look at it. And I can show you. What happened?
I think reports it back.
So Lamont is here somewhere. And the other dome is here and Gardner is here. So somewhere someone compared this all three things. But I will look at the composition and compare it with this current result and I'll try to see what it shows.
Beautiful work on the garden. That's
Thank
really-
you.